Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x minus 5 times x minus 2. For the math knowledge question, it tells us that b plus c is 180 degrees and a equals angle b. Well, that means that we can plug in a into angle b, and so angle a plus angle c has to equal 180 degrees, which is b. So that would be your answer there. We're looking at lesson 18 today. We're going to be looking at the triangle theorem. So hopefully you'll understand some triangle theorems after we get through this lesson. So we're going to start off with theorem 18.1. It's called the triangle angle sum theorem. You may already be aware of this, I hope you are anyway, that the sum of the measures of the angles of a triangle is always equal to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So let's look here. In the right triangle, MNO, angle O is 45. Find the measure of angle M if N is the right triangle. So we start off by drawing a triangle, and you may not need to draw the triangle, which is fine. But it tells us N is the right angle, and then here's M, and here's O. And it also told us that O was 45 degrees. So from there, we need to find this angle here. So the measure of angle M plus the measure of angle N plus the measure of angle O has to equal 180 degrees. So the measure of M is what we're looking for. They told us N was a right angle, which means it's 90 degrees. And they told us O was 45 degrees. So 90 plus 45 is 135. And then if you subtract 180 minus 135 is 45 degrees. So that's the measure of angle M. And then it says, what kind of triangle is this? This is an isosceles right triangle. Okay, so that's how that works. Some of y'all may not have needed to go through it. You could have just looked at it and known what it was, and that's fine. Some people needed to work it out. It's okay with me either way. Alright, so now we're going to look at some corollaries. So a corollary to a theorem is a statement that follows directly from the theorem. So it's kind of like a subset of the theorem. And so we're going to look at some corollaries that go along with theorem 18.1. So this is corollary 18.1.1. And the reason it's corollary 18.1.1, it's the first corollary that goes with theorem 18.1. So that's where the numbers come from. If two angles of one triangle are congruent to two angles of another triangle, then the third angles have to be congruent. So if we have two triangles here, and this one is 30, this one is 30, this one is 60, and this one is 60, and it's clearly not drawn to scale, these add up to 90, and these add up to 90. The total three have to add up to 180. So this has to be 90, and this one has to be 90. So if we know two angles are congruent, that means that the third pair of angles is also going to have to be congruent. Corollary 18.1.2, the acute angles of a right triangle are complementary. So if we have a right triangle, this is a 90-degree angle. These two have to add up to 90 degrees because the three of them add up to 180, and if we know this one is 90, the other two have to equal 90. So the acute angles are always complementary in your right triangles. The measure of each angle in an equal angular triangle is 60 degrees. If all three of your angles are equal, then 180 divided by 3 gives you 60. And then a triangle can have at most one right or one obtuse angle. So those are the corollaries that come from theorem 18.1. Some of them you may already be familiar with. So now we're going to find the measure of angle R in our triangle. Well, this is a right triangle. So we know that the measure of angle R plus the measure of angle P has to equal 90 degrees because they have to be complementary. So we don't know the measure of angle R, but we know that the measure of angle P is Y. So the measure of angle R would be 90 minus Y. And that would be your answer. Okay, so now we're going to look at this other triangle. And we don't have to draw it. We can if we want to, but we don't need to. We know that the measure of angle J is twice the measure of angle K. And the measure of angle P is 3 times the measure of angle K. And then we know that the measure of angle J plus the measure of the angle P plus the measure of angle K has to equal 180 because the 3 angles always add up to 180 degrees. So J is 2 times the measure of angle K and P is 3 times the measure of angle K. So 2 plus 3 plus 1 would be 6 times the measure of angle K equals 180, and then divide by 6. So the measure of angle K is going to equal 30 degrees. And then we can plug that in over here. So 2 times 30 would be 60 for the measure of angle J. And then 3 times 30 would be 90. So that would be the measure of angle P. And it says, and name the right angle. Well, our right angle equals 90. So angle P is the right angle. Okay, so that's how you can work through that one. Now we're going to look at remote interior angles. A remote interior angle is an interior angle that is not adjacent to a given exterior angle. So let me draw a picture of that real quick. So this is an exterior angle. This one is adjacent to it. So we want an interior angle that is not adjacent to this one. So this angle and this angle. This one and this one are interior. They're remote interior angles because they are not adjacent to this exterior angle. So we're going to look at theorem 18.2. It's the exterior angle theorem. The measure of each exterior angle is equal to the sum of the measures of its 2 remote interior angles. So this says that the measure of B should say the measure of angle DCA here is equal to the sum of this angle and this angle. And so I'm going to quickly go through how this is true. We know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees because these 3 angles are our triangle. And then we also know that the measure of angle BCA, this angle right here, which I called angle C, plus the measure of angle DCA has to equal 180 degrees. And so I can set these two equal to each other because they both equal 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle, instead of calling it C, I'm going to say BCA. And then that equals the measure of angle BCA plus the measure of angle DCA. And so these cancel because they're on both sides of the equation, and you're left with this equation up here. So that's the exterior angles theorem. Basically, you don't ever have to find this angle here as long as you have this information or these 2 angles. So we want to find the value of the missing angles and exterior angles. So if this angle is 50 and it's an isosceles triangle, this angle here and this angle that are opposite the two congruent sides have to be congruent. So I'm going to call them x. So 2x plus 50 has to equal 180. So 2x would equal 130, and so x would equal 65 degrees. So that would be the interior angles. For the exterior angles, we need to know what this is. Well, this interior angle is 65, and this interior angle is 50. So 65 plus 50 is 115. And so that would be your exterior angles. For our triangle ABC, we have two interior angles measure 54 and 62. Determine the measure of the exterior angle that is adjacent to the unknown angle and find the unknown interior angle. So the first thing we need to do is find the exterior. The exterior angle is going to equal the two interior angles that are not adjacent to it, which are 54 and 62. So if you add those together, you get 116 for your exterior angle. And then the interior angle is just 180 minus that exterior angle, which gives you 64 degrees. So that's how you can use your exterior angle formula. So now we're going to look at this one. A bridge uses cables to support its 2,000-foot span. Use the data in the image to determine the measure of the angle at the apex. That's at the top of the marked cable structure. So they tell us this exterior angle is 140. We don't know this interior angle, and we know this one is 25. So the measure of angle 2 plus the measure of angle 3 has to equal the measure of angle 1 from the exterior angle theorem. So the measure of angle 2 is 25. We don't know the measure of angle 3. The measure of angle 1 is 140. So if you subtract, the measure of angle 3 is going to equal 115. So that would be your answer for that one. Okay, so now we're going to look at another suspension bridge. It wants our exterior angle to be 8x, and it tells us our two interior angles are 6x plus 10 and x plus 5. What is the value of x in the exterior angle? So we know that this exterior angle has to equal these two interior angles. So 8x is going to have to equal 6x plus 10 plus x plus 5. So 8x is going to equal 7x plus 15. So that means that x would have to be 15. And then you're just going to plug in to find your exterior angle. So 8 times 15 is going to equal 120 degrees. So that would be your exterior angle. Okay, so now we're going to do our practice problems. So y'all try these two. Pause the video. Once everyone's finished, y'all can unpause it and I'll go over them. So it tells us that x equals 50. We want to find the measure of angle t. So we know that 60 plus 50 plus the measure of angle t has to equal 180. So 60 plus 50 is 110 degrees, plus the measure of angle t equals 180. So that means that the measure of angle t is 70 degrees. Okay, this time it says determine the measure angle t if x is 60. Well, we would do 60 plus 60 plus the measure of angle t equals 180 degrees. 60 and 60 is 120. And if you subtract, the measure of angle t would equal 60 degrees. So that would be your answer for those two. So let's see if y'all can try these two. And then once you're finished, unpause the video and I'll go over them. In our right triangle, PQR, one acute angle is 20. The other acute angle, well, we know that the two acute angles have to add up to 20. So one acute angle plus the other one, which is 20, has to equal 90 degrees. So x would have to be 70 degrees. We know they have to be complementary. So if one is 20, the other one is 70. Now let's look at this figure. In the triangle ABC, determine the measure of DAB. Well, this exterior angle is equal to these two interior angles. They are the remote interior angles. So 37 plus 28 degrees equals 65 degrees. So that would be the measure of the angle. Okay, let's see if y'all can try these two. Again, pause the video, and then I'll go over it after y'all have unpaused it. In our triangle, we want to make a sketch. So they tell us we have triangle JKL, and we have an exterior angle. So K measures 60 degrees, and the exterior angle at L measures 100. That's all the information they give us, so that's all we fill in. Don't plug in any other numbers. All they asked for was to sketch the given information. So if your figure doesn't look quite like that, y'all check with the neighbor and see if your figure is acceptable. You may not have it in this exact form, but it should still be K has a 60-degree angle, and your exterior angle is at L and measures 100. So now it says determine the measure of angle J in our problem. So this is our other remote interior angle. So the measure of angle J plus 60 degrees has to equal the exterior angle, which is 100 degrees. So the measure of angle J would equal 40 degrees. So there would be your answer. Okay, so now let's look at one more practice problem. Y'all try this one by yourself, and then I'll go over it after y'all have finished. So pause the video real quick. So we have four triangular faces. Each angle at the base of the face are congruent, and the angle at the apex is 68 degrees. So the apex means the top, so this angle is 68, and it told us these two are congruent. So I'm just going to make them angle A. So 2 times A plus 68 degrees is going to equal 180 degrees. So that means that 2A is going to equal 112. And then A, if you divide by 2, would be 56 degrees. So the measure of your congruent base angles would be 56 degrees. Okay, so hopefully you were able to get most of those practice problems correct by yourself. Now we're going to look at our challenge question. So a degenerate triangle is a special triangle formed by 3 collinear points. You can visualize this triangle by flattening one vertex onto the opposite side more and more until the triangle is so thin it looks like a line. Explain how the triangle angle sum theorem still holds for a degenerate triangle. So y'all pause the video and try this one, and then unpause it and I'll go over it. So on this one, there is a very small triangle. And then here is another one that's really, 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 really small. And eventually, as this vertex gets closer to this line here, it's going to flatten until it's just a line. So this angle here and this angle here are really, really close to being both 0. And then this angle here is getting really, really close to equaling a straight line, which is 180 degrees. And those three do add up to 180. So the triangle angle sum theorem still holds for a degenerate triangle, because if you add the 3, it still adds up to 180. So your homework is 1 through 30. So make sure that y'all do those tonight so we can go over any questions you have tomorrow.